Hello and welcome to another video on further maths course. And today we're going to talk about polar coordinates, and which is chapter 5 in the core PO2 for Edexcel and chapter 5 for MEI as well. Okay, there are 4 types of questions. And first one is changing between polar form and Cartesian form equations of the curves. This is only in Edexcel. MEI does not want you to interchange the equations. It just asks you to change the coordinates. Okay, so sketching the polar curves and checking with the graphical calculator. Obviously, we'll do that. Then number 3, find the area of the sectors. I will try and make the video of all the 4 types separately so that video doesn't get very long. So guys, we're going to do the first one, which is changing between polar form and Cartesian form equations. Okay, so what we need to do is we need to use x equals r cos theta and y equals r sine theta and x squared plus y squared equals r squared. Guys, this is fairly simple. If you just relate this to your mod arg form of complex numbers, and x is the horizontal distance from the pole or from the origin. Pole is, by the way, the origin in as equivalent in the Cartesian sector. Okay, so theta is the angle in anti-clockwise direction. So x is r cos theta, r is the distance between pole and the point, and y equals r sine theta, and x versus y square equals r square. So what we should do, we should change all the trig ratios in sine and cos form, and then start using this, multiply both sides so that every sine and cos term has an r multiplied to it. Okay, so I'm going to show that to you. How does that work here? Right. Right, so we picked up a question, which is exercise 5a and 3d. The question is r equals 4a tan theta sec theta. Okay, so we're going to try and change this into a Cartesian. This is going to polar. Step 1, do we change everything in terms of sine and cos? Yeah, so r equals 4a times sine theta over cos theta times 1 over cos theta. So I get r equals 4a sine theta over cos square theta. Right, so I would now like to take this to the other side. That becomes r square cos square theta equals 4a sine theta. And if you remember the steps in the PowerPoint, I did say that if you can multiply with r, so that every sine and cos term has an r. This one has it. This one doesn't. There's no r in this. So I multiply both sides by r. That gives me, that is r, sorry, this is just an r. Okay, now it will become r square cos square theta is equal to 4a times r sine theta. Okay, so this is r cos theta squared equals 4a times r sine theta, and we use r sine theta equals y, r cos theta equals x, so x squared equals 4ay, and that is your Cartesian equation for this polar, right? So we do the second question, exercise 5a again, and this is question number 3h, r equals 2 cos square theta. Right, so what comes to mind straight away? Let's make cos theta separately, so cos square theta. Right, so what comes here now, people? Cos theta, I got to have r next to it somehow. So I times this by r square on both sides, very important. Okay, because r square cos square theta will be r cos theta. This is r cubed over 2 is equal to r cos theta squared. Right? So, I mean, I could have let this 2 stay the other side as well. So what happens, people? This is r cubed is equal to 2 r cos theta squared. Now I can clearly see, people, this is important now. R cos theta is equal to x, and r cubed, I'll play smart here because I know r square, I know something in terms of x and y. What power of r squared give me this is 3/2. Right, so r cubed is equal to r squared, which is x squared plus y squared to the power 3/2. So x squared plus y squared to the power 3/2 equals 2x squared. That's it. This is it. If it's not show that question, I'll leave it here because I have been successful in making getting rid of r and theta from the question and getting x and y. So that is my second question. We're going to do a couple of examples now where we have to change Cartesian into polar, the other way around. Okay, so that's the next example. Right, so this is a Cartesian equation. We want to change this into polar form. So very simple, what do we do is wherever I see x squared plus y squared, I can read this as r squared. And there is a 2x there. I can replace x by r cos theta. So is equal to 0. So I get r squared equals 2r cos theta. I can divide both sides by to make it simple. So r equals 2 cos theta. There's no x and y left. Only variables are r and theta. So this is the polar equation. Okay, so we're going to be doing another question on this now. All right, so question number 4, part H. I can see there's a y there, there's an x there. I can replace y and x by r sine theta for y is equal to minus root 3 cos r cos theta plus a. So we bring these terms to one side. So I get here r sine theta plus root 3 cos theta is equal to a. And now guys, this is where you need to know chapter 7 in Edexcel I'm talking about of trigonometry in pure maths. We learn how do you change sine of a function sine theta plus p sine theta plus q cos theta in terms of r sine theta plus alpha or cos theta plus alpha u. This is a very peculiar question. I'm pretty sure you do know. If don't, we can have a lesson on that separately. But if you do change it, people, if you do change sine theta plus root 3 cos theta in terms of this form, and this will come out as 2 sine theta plus pi by 3. Okay, so we bring that back in here. That gives you r times 2 sine theta plus pi by 3 is equal to a. Okay, so what do? You take this to the other side. So r is equal to, because that's how all your polar equation should start. This is a over 2 sine theta plus pi over 3. And this can be written as, if you want to make it more simple, a over 2, 1 over sine is cosec. So it's cosec theta plus pi over 3. So that would be the polar equation for this Cartesian. It's very important. Once again, there's this method to work this out, not very difficult. Okay, you can, when you learn addition subtraction formulas, you can compare this with. Okay, we'll teach that later. So we will be, this is all about changing Cartesian to polars and polars to Cartesian. Let's do a few more examples now. Right, so this is another question 4i from the same book. Okay, so let's change this. Target is get rid of x and y and bring in r and theta. This is r sine theta is equal to r cos theta times r cos theta minus a. If I take this to this side, what's going to happen? R and r will cancel. This will be r tan theta, not r, just tan theta is equal to r cos theta minus a. Now target, guys, our polar equations looks like r equals something. So we want to make r the subjects. Let's take this to the other side. So r cos theta is equal to tan theta plus a. Right, r equals, make r the subject, divide everything by cos theta. That gives you r is equal to tan theta divided by cos theta. Okay, plus a over cos theta. And what's that going to give you? tan theta divided by cos theta can be written as, obviously take leave tan theta there. 1 over cos we know is equal to sec. This is tan theta sec theta plus a times 1 over cos is a sec theta. You can have sec theta common as well if you want to. You can write this as r equals sec theta and tan theta plus a. Okay, so this is the polar equation for this Cartesian. All right, guys, so that's our first video. In the second video, we're coming up with how do we do sketching the polar curves.